Poop. All right, we'll get started while the rest of the people come. Just wanted to review again, just ever so slightly, because this is the kind of thing that people need to see over and over again. Remember? Oops, just a second, gotta set my pen. I think after all these years, I'd remember that before I actually start. Remember, halides contain a halogen. And in a general formula, the symbol for halogen is X. So, but you'll never in a real formula see X. Like they would write C with H's, and then I or BR or CL, but they would never just write X in the formula. That's just the X here is just the generic way to show it. And remember that the 5 and the 4 are footnotes. They're not actually part of the whole, they're not actually part of the formula. Also remember that R is any combination of C and H. It's the regular stuff. And that this C is actually part of the R. They actually go together. I just added the C so that I could emphasize that they're attached to a carbon, or when they're attached to the same carbon, or whatever the case may be. Now, let's see. Notice here, if you didn't make the change already, notice right, nope, wrong one, sorry. Right here, that it does not contain at least on, it contains at least one hydroxyl group. So, whoops, having trouble clicking the right thing today. So alcohols, they have an OH that's attached, that's a bond, not a negative. and no other oxygen on that carbon. And again, this whole thing can be the R. So for alcohols, we're looking for just an OH. For halides, we're looking for a halogen. And it's okay, it's at least one, by the way. So so you can actually have more than one. When I was in college and for a while, I don't know when they changed, and in high school, back in the 70s, if you took something to the dry cleaner, that something would come back with a very distinct, I don't know if it was bad, I don't know if it was good, but it was distinct smell of dry cleaning. You could tell when somebody was wearing something that had been freshly dry cleaned, because back then, what they used to use for dry cleaning solvent was something called carbon tetrachloride, or a carbon and 4 chlorines. Now, that is a substituted hydrocarbon with all of the hydrogens having been replaced with chlorine. They do not use carbon tetrachloride anymore. I can't remember. It either was discovered to be a carcinogen, which means cause cancer, or it was discovered to be an ozone eater, or both. I don't remember right now. But it's at least one. It can be more than one halogen in the halide. Ethers, O between two C's, and remember these can collectively be the R, but only an O between two C's. Aldehydes had a double bonded O, only a double bonded O on an end carbon, and ketones, only a double bonded O, not on an end carbon. And notice this, the R in this case cannot be a hydrogen. And again, remember that this bend doesn't mean anything. I could easily have been written RCR with the O going either down or up. It doesn't matter which way the O goes. Carboxylic acids, double bonded oxygen, and hydroxyl group on the same carbon. If they're on different carbons, like C, 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 double bond O, and OH, if they were on different carbons like that, then it would not be a carboxylic acid. It would be two things. It would be an alcohol, and since that's an end, it would be an aldehyde. So it is possible to have multiple of these substitutions, multiple kinds of substituted hydrocarbons in the same molecule. So they have to be on the same carbon. This would have to be here to change this to a carboxylic acid. So esters are like combining a ether and a aldehyde or ketone, depending on where the double bonded O was, double bonded oxygen, and an oxygen between two carbons at the same place on the same carbon, either on this carbon or on this carbon. So at the same place, or in other words, on one of the same carbons. Now, that's as far as we got before. I brought a molecule kit home with me, but now I'm back to my cell phone hotspot with a kind of an iffy connection. So we will see if I have enough bandwidth here in my data stream to actually be able to show you this. So, carbon. Nitrogen. Let's see. Nitrogen, I forget. Nitrogen is blue. So, if I have a nitrogen, that would be 1R on my nitrogen. And remember, R's can be all kinds of combinations. 2 R's on my nitrogen. I'm doing the simplest possible R. Actually, that's not quite true. I'm doing the simplest possible carbon and hydrogen R. So this would be nitrogen. Okay, let's see now. We'll be back here in a minute. So notice we've got N, R, R, R. Nitrogen, N. If you can see in my little inset there, nitrogen, N, 1R, 2 R's, and we need a third R. Now, here's the thing that throws people. In this case, the third R can be just a hydrogen. So now we've got, let's see, 1, 2, 3 R's. You could actually have 2 R's be hydrogen. So we've got nitrogen, blue ball. Let's see, get this rotated right. Nitrogen, blue ball. That counts for an R. That counts for an R. And whoop, that counts. This counts for an R. So for amines and amides, an R can be a hydrogen, but all 3 R's can't be hydrogen, because if all 3 R's are hydrogen, man, I would love to ask this question. So, and I would love to be able to flick a lifesaver at you if you could actually figure it out. If you have a good idea why this can't be an amine, why these can't be 3 R's, you know, reading, writing, and arithmetic, reading, writing, yeah, it's 3 R's. If you really can figure out why these can't be 3 R's, you go ahead and open your mic and tell me what you think. Anyone? 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 Yeah, that was scary, wasn't it? No one? These can't be 3 R's. This cannot be an amine because it is not a hydrocarbon, not even a substituted hydrocarbon, because there's no carbon on it. This molecule would actually be ammonia, not ammonium. That would be NH4 plus, but it would, this molecule would be ammonia. All right. So notice right here. The R can be hydrogen. Better add this, up to 2 R's. But not all 3. Then it's not a hydrocarbon anymore. Well, what in the world happened there? I didn't touch anything. All right, the last one here then on our list is amides. Now, here again, we have a case where our 2 words are so similar to each other that probably have some confusion. Amine with an N and amide with a D. It's the only difference in the spelling. By the way, why they say long I for amide and why they say E long E for amine, I have no idea. But notice there's only 1 letter difference. So in this, we've got the N and the double bonded O on the same carbon. Same carbon. So this is like an aldehyde or ketone and an amine combined to the same, an amine combined to the same carbon. So this would be like, that's not what I want to take apart. Just a minute. That would be like, there's 1 R. And there's a nitrogen with 2 hydrogens that can count for R's, or they could be any other combination of carbon and hydrogen. And then one of the carbons has a double bonded, one of the carbons has the double bonded O. Come on. All you can see is my hands because I have to see what I'm putting together and I'm on the other side. All right, so let me find the sweet spot to show this. Double bonded O, see, double bonds attached to a carbon, black ball, which is attached to the nitrogen, the blue ball. And then on the nitrogen, there is 1, 2 more R's. So the double bonded O, 2 bonds, and the nitrogen are the key we're looking for on the same carbon. That makes it an amide. If this double bonded O wasn't there, it would be an amine, except we'd have to put, whoops, wrong side. We'd have to put our hydrogens back on that. Yes, Sid.
So do you have to have the R attached to the nitrogen when you make the amide, or is it just for, you can just leave that off as long as it's just the nitrogen and the double bonded oxygen on the carbon?
The hydrogen, you usually show it, or at least put the empty line. So remember how we can just draw lines with nothing on the end, and those are understood to be hydrogens. So you would want to show, let's see if I can. So the thing I just made, the formula, the structural formula would be C for hydrogen, 3 hydrogens, connected to a nitrogen, which was connected to a carbon with a hydrogen and a double bonded O. Now, I can't do it like this. I either have to put a blank line to show it's a hydrogen, or I actually have to write the hydrogen. Does that answer your question?
Yep.
All right. So those are the 9 substitute hydrocarbons. The quiz today asks questions about them. There will be more quiz questions asking about them. I probably will end up giving you a worksheet that is a list of them, and you have to name them. Actually, tomorrow we will do some of that. I will give you a whole bunch of formulas. We'll do it right together on the screen. I'll give you a bunch of formulas, and I don't need a camera anymore, so let's get rid of that. And we'll do some practice with these tomorrow. And then after a couple of days of practice, I'll probably end up giving you a worksheet to do on your own. All right, now we're to the next section, which is biological molecules. Or this is the section of what we would refer to as biochem. And biochem is a very important area. If you had any kind of interest in biology, or let me put it this way, anyone who had interest in biology and chemistry and was looking for a way to combine them, that would be an excellent area for you to go into in college. And there's a lot going on in biotech, and biotech would be an extension of biochemistry. So that is, if you're interested in that kind of thing, that's an excellent area. Now, it's also very complicated. So for now, I'm just going to basically give us the overview, give you the overview, and then we'll be working on it for the rest of the year as we practice the substitute hydrocarbons. So there are 4 basic kinds of biological molecules, and these are in the notes. I'm not going to scan through the notes and overshoot and go back and all that kind of stuff. The 4 kinds of biological molecules are carbohydrates, which you see right here, carbs is short for carbohydrate. So, you've heard of complex carbs, and that's complex carbohydrates. We talk about carbs in the diet all the time. You should be familiar with the word carbs. I can't remember, this might not be the order in the notes, but a second group is lipids. Lipids. And you have heard of lipids, but you may not have heard of them called lipids. Lipids are the fats and oils, and basically fats and oils are essentially the same thing chemically. It's just whether they're solid or liquid at room temperature. So you've heard of carbohydrates, you've heard of fats, proteins. You've heard of proteins. I mean, meat, you need it in your diet. Beans and nuts are a good source of protein from plant. I mean, you've heard all of this stuff because we talk about in our proteins in our diet quite a bit. The fourth category, which is not talked about in diet because you get enough in your diet without even trying, is nucleic acids. Now, these are the four categories of four kinds of biological molecules. The problem is they're very complicated, and that's where the confusion comes in. So for each of these, and again, this is just introduction, it's all in the notes. We have most of these, all of these are made of smaller molecules. In some cases, like starch, hundreds of smaller molecules put together. So we have, under these, we've got the subunits. See, like right here, the subunit for carbohydrates. The subunits are what they're made of. Like starch is hundreds of glucose molecules hooked together in a chain. And then you've got the subgroups. And the subgroups are different kinds. So carbohydrates, I've got different kinds of carbohydrates. As I mentioned just a minute ago, you've heard of complex carbohydrates. And maybe if you think about it a little bit, you might realize that when somebody says complex carbohydrates, they're probably talking about starch in the diet, or possibly, you may not pick up on this one as easily, but when people talk about complex carbohydrates, they're talking about starch or fiber. But then sugar is another kind of carbohydrate, but it's a completely different group. It's a completely different category of carbohydrate. So subunits is what it's made of. Subgroups are the different kinds within the category, like carbohydrate or lipid or protein. And people get these two mixed up. So you're going to want to pay close attention to the subunits versus the subgroups. See here, subunit and subgroups. And then within each of these, we've got all kinds of different uses, and some of the uses overlap with other categories or subgroups, and some of the uses do not overlap. So it is complicated. There's a lot to keep straight, and we'll be going over it a little bit at a time and trying to make it as uncomplicated as possible, but it'll still be somewhat complicated. So I'm going to stop here for today. And if you have any other questions, ask now. Otherwise, I'm going to end the meeting.